All right, guys, so today we are solving the quadratic equation. We are going to use the quadratic formula. So what every good student needs is, of course, to learn the song. And so my students are going to help you learn that. Ready? So here we go. Here it is. Ready? 1, 2, 3. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. All right. Now, let's try that again, boys and girls. Okay. Ready? Here we go. Should I erase it? No. Let's try. Let's give them a practice run. Ready? X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, now I know the tempo's a little slow. I'd like you to pick it up. Okay? I can't use my hand and write at the same time. So ready? Here we go. 1, 2, 3. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now that was perfect. Now we're going to try it for people out in internet land with no clues. So ready? Let's try it again. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Woo! There you go. X equals negative b. But I forgot to write it all. All right. So that there, I stopped writing. I was standing and I was directing. All right. So that there is the quadratic formula. 1.49 seconds, 1 minute, 49 seconds of learning the song. Okay, so with a quadratic equation, the general formula for a quadratic equation is y equals ax squared plus bx plus c. So we take our a, our b, and our c. We figure out what the coefficient is, the a, the b, the c, and we substitute into the quadratic formula. So in this case, what would be a? 2. What would be b?
5.
Positive 5. And c?
Negative 3.
Perfect. And so we just substitute that in. So negative b, which would be negative 5, plus or minus, b squared is 5 squared, minus 4, which is part of the formula, a is 2, times negative 3. Now, the one thing I want you to watch is that now that I have a negative here and a negative here, that makes that whole section what? Positive. So I've got negative 5 plus or minus. Let's simplify that. Negative 5 plus or minus the square root of, what? You know what? I'm going to move my 25 minus what? Or plus? Plus 24 all over 4. 25 and 24 simplify to what? I like you working vertically. Do not work sideways the way my PowerPoint is. Got it? Do not work sideways. So 25 and 24 simplify to 49. And we've got a very nice number there. So that's negative 5 plus or minus 7 over 4. Negative 5 plus 7 is what? 2 over 4. And negative 5 minus 7 is negative 12 over 4. So it's going to end up being 2/4 or, 1/2 or negative 3. Questions? Super easy, huh? Okay, can we move on?
Yes.
All right, so now we're going to do something called completing the square. We did this last night for homework, only this time we're doing exactly what we did last night, only this time, head in the game, please. Thanks. Only this time, and you will be quizzed on this, doing this without numbers. So, I'd like you to really stick with me. Okay, so in order to complete the square, what did we do last night for homework? Zach, first we subtract c, right? And then we're left with this. What would I do next? Daniel?
You would find divide b by 2.
And then, right, we're going to take the b. We're going to divide it by 2. Whoops, sorry. Sorry, oh, yeah. But we forgot. Sorry, I'm really blowing it here. Okay, we forgot that about, we have a lead coefficient. So what do I do with that lead coefficient? Divide all terms by the lead coefficient. Good. And now we're left with x squared plus b over ax equals negative c over a. Now, what do I do with the b over a, Daniel, now?
Now you divide b over a by 2, which is the same as multiplying by 1/2.
Multiply it by 1/2 or divide by 2. Dividing by 2 is the same as multiplying by 1/2. Go on.
And then you square that, so it becomes...
Hold on. So I'm going to square that, and it becomes what?
b squared x.
B squared over...
b squared over 4a squared.
4a squared. Good. You guys with me? So we are adding that to both sides. We are adding b squared over 4a squared to both sides. You with me? Yes or no?
Yeah.
Okay, now all I'm going to do on the next step is turn this around. I'm going to turn this around. That's it. I'm going to flip the terms. Okay? So, you with me? Did you see what I did?
Yes.
I just flipped. All I did was reverse the terms. And why am I doing that? Well, I need some more room. Okay? I need more room. Okay, I'm going to also need a common denominator on that side. So what do I need to multiply it by? 4a over 4a, right? So I'm multiplying by 4a over 4a. And then we've got b squared minus 4ac. And they're both over 4a squared. Now, how do I factor this part? What does this factor to, Daniel?
X plus b over 2a.
B over 2a, and this becomes equals b squared minus 4ac, and isn't it all over 4a squared? Right? They have the same common denominator. You guys with me? We have this as squared. Okay, questions? Are you guys still with me?
Yeah.
Now what can I do next? I think I skipped a step when I was doing it. Okay, what would I do next? How do I get rid of the square? Yep.
You root both sides.
We root both sides. So we're going to take that entire thing and we're going to put a square root on it. And now what do I get on this side, on the left side? Yep.
X plus b over 2a.
Close.
Well, in absolute value.
Absolute value x over, okay, absolute value x plus b over 2a. Sorry, I shouldn't have made that line so long. And then equals, I cannot, b squared is a perfect square, 4 is a perfect square, but these two are not, so I can't take a piece of a binomial. That's got to stay under the radical. And what's the square root of the denominator? Is 2a. So now to lose that, are you guys with me? Yes or no?
Yes.
To lose the absolute value, what do I have to do? Plus or minus. Okay, now what? Chris? How do I solve for x?
We subtract b over 2a.
From both sides. And then we get x equals negative b over 2a plus or minus the square root of b squared minus 4ac over 2a. So can't we just say that this is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a? And that, my friends, is where we got the quadratic formula. So, This is called deriving the quadratic formula by completing the square. So I'm going to go back. And I'm going to do it really quickly because we've got a very long lesson. And we're going to go back and ask you one more time the steps. So step 1, what do we do?
Subtract C.
Subtract C. Next step, what do we do? Divide all terms by A. Okay, now, what do I do to B over A?
Multiply by 1/2.
Multiply it by a half and then square it. And now we have B squared over 4A squared. So we add it to both sides. Are you guys with me?
Yes.
And now we need our common denominator on the right. We need to factor on the left. Common denominator. Oh, first I'm going to switch the terms on the right. Right? Because I need CA. So C, I need to multiply C over A by? 4A. Okay, and then we get B squared minus 4AC. And I can factor the left side. B squared minus 4AC all over. I probably would have just written it all over 4A at this point. Skip this step and gone right to this next one. Now what do I do with that? Don't be rude, just root it. Both sides. On the left side, what do I get? And on the right side, we put each part under the radical. The top, can we take a square root of the top?
No.
Okay, and what about the bottom? Becomes 2A. What's the next step?
We subtract B over 2A from both sides.
Okay.
We can have
And then we get x equals negative b plus or minus b squared minus 2, negative b over 2a plus or minus b squared minus 4ac over 2a. But instead, let's just put it all over 2a. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, so my suggestion to you is that you practice this. It is very easy. It is just you need to do it several times. We will give you a quiz on just this. So you will need to derive the quadratic formula, and each step will matter. Yes, go.
So like instead of completing the square with like the variables already known as what the numbers would be, we should replace the numbers into this formula.
Yeah, we're using ax squared plus bx plus c equals 0. Okay, so now we're going to actually solve using the quadratic formula. A lot of careless errors in math. So the first thing we have to do is we got to write our formula and we have to determine our a, b, and c. What is my a?
3.
What is my b?
-4.
Good. And what is my c? Excellent. So now we're going to substitute in negative 4 plus or minus negative 4 squared minus 4 times 3 times negative 1. I like to write the double negatives just so I don't forget a negative. I overwrite my negatives because I just don't want to lose one. Negative 4 plus or minus the square root of negative 4. So that becomes 4 plus or minus what? 16 plus or minus? Plus what? 12 over?
6.
Good. And so it's 4 plus or minus 16 plus 12 over 7. Over 6, sorry. Now, we have two things we can do right now. I can estimate. They want us to round to the nearest hundredth. Now, I can estimate the 28, and I'm going to show you how to do that. So 28, remember, 28 is between 25 and 36. So my guess is going to be, this is 5, this is 6, it's like 8 digits, and this is 3 digits. I'm going to say 5.2, 5.3. Okay. I'm going to go with 5.3. If I check it on here, it's 5.29. So I said 5.2, 5.3. Now, if I'm doing this, now this is an estimation, and I will allow you to go to the 10th. Okay, so if I have, it's going to be 4 plus or minus, the square root would be 5.29, right? All over 6. Okay, so that means 4 plus 5.29 over 6, and then 4 minus 5.29 over 6. So this is 9.29 over 6, and this is 1.29, right? Negative 1.29?
Yes.
Over 6. So now we're doing division, 6 into 9.29. So 6 goes once. I have a remainder of 3, bring down the 2. It goes 5 times. I have a remainder of 2, bring down the 9. It goes 4 times. It's 24. I have a remainder of 5. I bring it down. My next one would be 8, right? They want me to round to the nearest hundredth. So what would it be?
1.55.
It's about 1.55. And then the next one, 6 into 1.29. It goes 0. It goes 6. I have 0 remainder. It goes once. Right? I have 3. It goes 5 times. So I would say, what did I do? It's 2. So I would say it's about 22, 0.22. 0 and 22 hundredths. Negative. Okay, questions? Negatives. Okay, so now, yes.
Would it be easier if you could just leave it as a
Reduced radical?
Yeah.
Well, but it didn't ask for that. So you have to be able to do both.
No, I mean.
Okay, so now let's look at my PowerPoint. They choose to reduce the radical first. Is that what you're talking about? And then estimate? The problem is that for me, it's harder to estimate the lower radicals. So 7 is between 9 and between 4. So I would say this is 2, it's 3 away, it's 2 away. I would say it's about 2.6. Right? So 2.6. So if I'm estimating that to be 2.6, oh, wait a second. 4, whoops. Let me hold on. Okay, if I'm estimating this to be 4 plus or minus 2 times, oops, here we go. 2 times, what would we say, 2.6?
Yeah.
I get 4 plus or minus, oops, I'm forgetting my 6, I'm a mess here. All over 6, I'm doing 4 plus or minus, what does that become, 5.6?
5.2.
Oh. 2 all over 6. This becomes what? That becomes 9.2 divided by 6. Are we exactly at the same place? No, we're slightly off. But I just feel like I'm better when I estimate bigger numbers. It's hard to get closer when you're so little. Now, a third thing you can do you understand what I'm saying? So 6 into 92 is 1.53, which is pretty close. So again, if you're doing about, if you're estimating about, and then 4 minus, it would be negative 1.2 divided by 6, and it would be about 0.2 negative, right? Okay, so it's just a little, the smaller the radical is that you estimate, the harder it is to be more accurate unless you're doing it the method that Sophia taught you. Okay, where you create that fraction and then create the all right, last method that you can do. I'm noticing that all terms have something in common. There are 3 terms here. This term, and this term. If that's the case, I can divide out a factor of 2. Or I can do one of 2 things. I can factor. I mean, there's multiple ways to go here. I factor the 2 out, and then I divide by the 2 out, and I'm left with 3 here. And then try and do the estimate. I'm sorry, this is a 1. Or I can say 2 goes into 2 once, twice, and 3 times. So it's 2 plus or minus rad 7 over 3, and then do the estimating. Does that make sense? Yes or no?
Yeah.
Okay, do you feel okay about the quadratic formula? Do you need more time, or can we move on? Okay, good, because I'm going to skip the next one. Okay, please stop. All right, if there's no C, what do I do? What? Subtract 7, there is a C. And then we can find our A, B, and C. Right? If it's a binomial and it were x squared plus 3x, what would my C be? 0. Would I use the quadratic formula? Probably not. I just factor x times x plus 3, you know. Unless, really, this is going to be about you following directions. Because there's multiple ways. And on SAT, on standardized tests, they're going to ask you, show me completing the square. Show me quadratic formula. Show me, you know. So you're going to have to kind of show your work. All right. There's something called the discriminant. Inside the quadratic formula, the discriminant tells us a lot. The discriminant is the b squared minus 4ac. Okay? And it's used to find the number of roots of the quadratic. Okay, the quadratic equation are used to find exactly what are the roots. But the discriminant tells us how many roots we have. Do we have 1, 2, or 3? For instance, I'm going to draw what's on the board there. In this situation, when I have a graph that looks like this, how many roots do we have? Okay, what are roots? X-intercept. So tell me, on that graph, how many roots do we have? 0. 0 roots. Okay, on this one, how many do we have? 1. And on this one, what do we have? 2. I have 2 here, 2 roots. I have 1 here, 1 root. And here, I have no roots. What the discriminant does is it tells us how many roots we have. So, if I take the b squared, if b squared minus 4ac is greater than 0, meaning if it's a positive number, greater than 0 is a positive number, we'll have 2 real roots. If b squared minus 4ac equals 0, like the square root is 0, right? We'll have 1 root. And if b squared minus 4ac is less than 0, we'll have no real roots. Meaning, when it's less than 0, it's the square root of a negative number. Right? If this inside of here equals a negative, aren't we going to say no real roots? That means it's a floater. It's going like that, or it's down here. Yes?
If it's greater than 0, how can I have roots? Well, so what is 0 representing?
It's going to be like this.
So
Okay, if it has, okay.
What are the 2 roots then? Is it greater than 0?
What?
How would there be 2 roots?
If it's a positive number,
Okay.
it's going to have 2 roots. If it equals 0, it's a perfect square trinomial, and it's going to be the square root of 0, so you're going to be plus or minusing nothing. You're just going to end up with negative b over a number.
Oh, okay.
Right?
Yeah.
And if it's b squared minus 4ac, and this radical here is like, it's like negative b plus or minus the square root of a negative number, we're going to say no real roots. Does that make sense? If it's a positive number, we know there's 2 roots, even though it's not a perfect square. Okay, and if you get x equals 0, b squared minus 4ac equals 0. So determine the number of roots for the quadratic equation. So we find our a, b, and c. A is 2, b is negative 5, c is 3, and we substitute it into what? B squared minus 4ac. So negative 5 squared minus 4 times 2 times 3. And then we have 25 minus 8 times 3 is 24. It's 1. So how many roots am I going to have? 2. You are right. 2. Because it's positive, it means that that portion under the radical is going to be a positive number. We'll have 2 roots. Any questions? Sorry, it's cutting off my numbers. Okay, let's try the next one. Why don't you do this one? Pause the recording and you guys try it. Okay, so my A is negative 1, my B is 4, my C is negative 7. I'm doing B squared minus 4AC, 4 squared minus 4 times negative 1 times negative 7. Uh-oh. I'm seeing 3 negatives. So 16 minus what? 28?
Yeah.
Isn't that a negative number?
Yes.
So how many roots? No real roots. Good. Next one. Okay. Try the next one. Yep. What?
If it's no real roots, then what would be the non-real root?
You would just say no real roots. You wouldn't say non-real root. Doesn't sound right. I'm not sure why. What's happening is you can graph it, but in your graph, what's happening is it's not touching the x-axis. It's up here, it's down here, it's down here, it's up here. Okay?
So would it be no root?
No real roots, yes. All right, let's check our work. B squared minus 4AC. So I'm doing negative 6 squared minus 4 times 1 times 9. 36 minus 36, what does it equal? 0. It's going to have 1 root. It's going to be sitting on the x-axis. Notice, perfect square trinomials are the ones that have 1 root. Okay? All right, so now let's use this. How can this help us? One real solution. So instead of, let's say you're given a question and you have to match the equation to the graph. Where before we had to do the axis of symmetry and the vertex and figure out all this stuff. Well, now we can just use our discriminant. Everybody say discriminant. Okay, the discriminant. Shh. So the discriminant here, remember my A is 2, my B is negative 1, my C is 1. So I'm doing B squared minus 4AC. So it's 1 squared minus 4 times 2 times 1. 1 minus 8. What does that equal to? Negative 7. Which graph goes best? No real roots. Which one goes best? B. Because it has no x-intercept. So this would be B. You guys with me? Yeah? Okay, next one. As we find the discriminant, we find that it equals 9. Which one does it go with? C. Much easier to use the discriminant then 2. Okay, last one. I'm getting 4 minus 4 equals 0. Which one is it? A. You guys with me? Yes, you understanding how to use that? All right, so now here's another way they could say. Tell whether the vertex lies above, below, or on the x-axis. Well, step 1. It's positive, so we know it opens up, right? Okay, so I find my discriminant, and I find that it's a negative number. So let's draw this, right? I know it opens up, and it has how many roots?
No.
So it has to be up here. So what would we say? Does the vertex lie above, below, or on the x-axis? Above. Do you understand?
Yeah.
Okay. So now we would say that. Okay, the next one. Which way does it open? Down. It opens down. I'm going to find the discriminant. How many roots is it going to have? 2, because it's positive. Now, does the vertex lie above, below, or on? Above, yes. Why? Because we know it opens down, and it has 2 roots. So it has to be here or here. Okay, questions? Yes.
Why does it matter if it opens up or down?
It just helps you to determine where the vertex is. Like, I mean, sometimes I have people graphing out of, like, remember when we were doing 12-4? Some people on some of those graphs were, like, all over the place, like, had no clue. If you know the discriminant, you know where the vertex, you can check yourself on your vertex, right? Okay, are there any questions on how to use the quadratic formula? That is the lesson.